All we have to do is find the limit as n approaches infinity. So limit as n approaches infinity of n factorial over 2 to the n. Okay, this is a question of magnitudes, like a horizontal asymptote sort of thing. So enormous numerator, enormous denominator, but which one's enormouser numerator is? So this one is going to be greater than 0. So therefore this does not equal 0. So the series is going to diverge. That's all I know. That's all I can really say for sure, is that we have a divergent series. So diverges. Okay, that diverges. All right, move on to the next one. The limit as n approaches infinity of e to the n over n plus 1. Okay, who's more powerful, numerator or denominator? Numerator. For that reason, this thing does not equal 0. Therefore, we have a divergent series. This one's easy. This test for divergence is going to happen off the top of your head. You would look at it and say, oh, does this approach 0 or not? Oh, it doesn't approach 0, not a chance of convergence. So definitely divergence. All right, let's do the next one. The limit as n approaches infinity of negative 3 to the n. So as I plug in larger and larger values for the exponent, we're going to have, for example, negative 3 to the 1, negative 3. Negative 3 squared, positive 9. Negative 3 to the third, that's negative 27. So if you wanted to list the terms, you don't have to, but if you did, you would have negative 3 plus 9 minus 27 plus 81. Notice they're getting further and further from 0. So I know that this thing is approaching infinity, negative infinity. Well, here's what I do know. Doesn't equal 0. So this one's going to diverge. The series diverges. All right, we're going to flip the paper over and keep on moving with 4 more examples. And here they are. Now things get fun. Woohoo! Really fun. By the way, you can L'Hopital a lot of these things. So let's switch colors. Switching to purple, no reason at all. The limit as n approaches infinity of cosine of k pi over natural log of k. And we are going to continue with this process. So let's look at that. We have, let's see, cosine of k times infinity. Well, okay, well, let's just think about this. Cosine is going to be stuck between negative 1 and 1. Cosine has no chance of ever getting out of negative 1 and 1. That is its range. Now, because there's a 1 in the front. If it was a different number, still would be stuck between those two things. So we're going to have some number that is in magnitude very small divided by a number that gets larger and larger and larger very slowly. But who's larger? Which one has more magnitude, denominator or numerator? The denominator. So this one equals 0. So what can we say? Can we say it converges? No, we can't. This one is inconclusive. All right, next one. Oh, that's geometric. I hope you noticed that. I really hope you noticed that. I think that's worth writing in green. This one's geometric. It is geometric with an R value of 3/2. Automatically, you know that this thing is going to diverge, right? But that's not the point of this lesson. So let's do this. The limit as n approaches infinity. This is a fun one because you can rearrange a few things. And it may not be obvious what to do with this infinity, but let's just kind of keep manipulating some stuff. This is the limit as n approaches infinity of 3. I don't know why I put that parenthesis there. We'll go with it. 3 times 3/2 to the n times 3/2 to the negative 1. I'm doing this just so we can get in the habit of rearranging some of these because that's going to come in handy later. It's going to be a very necessary skill. And so let's keep moving with this. This is the limit as n approaches infinity of 3/2 to the n, and then this to the negative 1 is going to be 2/3 here. And so 3 cancels with 3, and it's going to give me the limit as n approaches infinity of, let's see, 2, just 2, and then 3/2 to the n. All right, so may not have helped me much, but I got some really good practice in manipulating this thing. So let's keep going. what we have is, again, geometric. I already know it diverges, but I want to use the limit as n approaches infinity, which is the nth term test. I want to know what happens at the nth term as n approaches infinity. So as I approach infinity with this, I've got an enormous exponent, a number greater than 1 to a huge exponent is going to give me a big number, and then you double it. So this one is not equal to 0, and therefore this one diverges for a couple reasons. There's one reason, and again, there's the other. There's the other. Okay, last two problems. The next one is geometric also, and we could go with the whole geometric thing, and we can be like, oh, well, you're geometric. Geometric, and r is -1/4, which is between -1 and 1, so we have convergence, right? That's not the point of this lesson. The point of this lesson is that we do this. The limit as k this time approaches infinity of 1/2 -1/4 to the k, and I'm going to raise this number to a higher and a higher and a higher and a higher power. And as I do, of course, there's a negative, so my signs are going to alternate, but I'm just thinking of the magnitude of it. Let's not worry about the alternating signs. Let's worry about the magnitude. Well, let's not worry about it. So as we plug in larger and larger and larger numbers for k, this fraction is going to get closer and closer and closer to 0. So we're going to have a number close to 0 times 1/2. So this is going to equal 0. So I want to be very clear with this. The nth term test, kth term test actually, and I want to be specific with that. The kth term test is inconclusive. Based on this, only this, I cannot say convergence or divergence, right? That was the part I muddled through in a previous video where I was talking about if it does not equal 0, we have divergence. If it does equal 0, then I couldn't say either way because there are some series where the terms approach 0, but they actually would diverge, right? So there are exceptions to this where you would say, oh, if it equals 0, it's going to be convergent. Not necessarily. Not necessarily, right? All right, there. Said it again. The kth term test is inconclusive, but dun, 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 it converges because it is geometric and r is -1/4. Okay, so kth term test got me nowhere, but I did know that. Sentence fragments over here. Terrible idea. All right, next one's going to be pretty easy. Let's figure this out really quickly. The limit as n approaches infinity of n squared plus 1 over n plus 1. All right, you can L'Hopital this one if you want to, right? But who's more powerful, quadratic or linear? Quadratic, and that's your numerator. So this one does not equal 0, so this one is going to diverge. The series diverges.